Now we're going to talk about bar graphs, line graphs, and pie graphs. All right, so I've got a picture here of a bar graph. Let's notice how it's different than the histograms we looked at earlier. Histograms will always have numbers on the x-axis. On the other hand, we will use a bar graph to represent qualitative data. Let's notice in this case, type of cereal is on our x-axis, and it is not numerical. It is things like cornflakes, Cheerios, Life, and Kix. All right, and of course we do have numbers, the number of votes for that particular cereal on the vertical axis, but our horizontal axis reflects this qualitative information. Now, notice that we can pretty much tell almost everything there is to know about this data from this chart. We can tell how many people chose cornflakes. If we look over here, there were 4 voters who chose cornflakes. We can tell how many chose Life. There were 6. If we count up each of these bars, we can tell how many total number of voters there were. There was 4 plus 2 plus 6 plus 3. Now, we can also, in bar graphs, represent more than one set of data and compare them. So here is a bar graph that compares males to females when it comes to their participation in selected sports in New Zealand. And notice when we're comparing, we have in our key, or we have a key that tells which bar represents the males and which represents the females. If we want to, we can compare more than 2 groups, but we have to have a key over here telling us what we are looking at. Now, notice with the bar graphs, our bars are always separated from one another, unlike our histogram. And in this instance, we can see that if we look at football, there are, it appears to be about 110 males who chose football, and it's 110,000, according to this over here, males who participated in football, as compared to, looks like perhaps 40,000 females, according to this bar chart. Now, when we look at bar charts, we want to make sure things are appropriately labeled on both the left for our vertical axis and on the right for our horizontal axis, and that these numbers are all evenly spaced here on the left. All right, so now let's take a look at a different type of graph, a line graph. Oops, I've got 2 of them here. Line graphs tell us about changes over time. So we will notice that the horizontal axis on a line graph will always involve time. Now notice in this case, the horizontal axis is days, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, whereas the vertical axis tells us the number of push-ups in this case. So we can tell that this individual on Tuesday did 25 push-ups. On Wednesday, the individual only did 5 push-ups, 20 less than they did on Tuesday. And we can compare over time. And with these line graphs, we always connect whatever dots of data we have. So we end up with a line or a line segments. Now, we can also put 2 different graphs together and compare, as long as we're comparing essentially the same idea over the same time period. So notice that in this case, we are comparing the population growth of Australia to the population growth of New Zealand. And notice that we've got a key over here to tell us which line is which. So Australia is the green line and New Zealand is the blue line. And clearly Australia has a higher population and more growth than New Zealand. And we'd expect that to be true. They've also extrapolated what they expect the growth to be after a certain period. And it looks like Australia is supposed to really according to whatever prospects they think are going to occur, that population is going to grow quite dramatically. All right, and then lastly, let's look at a pie chart. All right, now the pie chart, we want to be sure that a pie chart always represents every contingency in whatever we're looking at. So what I mean by that, pie charts always represent percentages. So we will see that every part of a pie chart is a percentage. And notice in this particular pie chart, every single piece of pie represents the percentage of your diet that should be that certain thing. So if we look at the green here, this 23%, and that corresponds to, it's a little bit hard to see in the key over here, but to protein. 23% of our diet should be protein. This blue, 30% of our diet should be fruit. And notice if we add up everything here, it's 100%, and that should always be the case on a pie chart. Also, you'll notice there is this other category. It's making sure on a pie chart that we have taken into account anything that we might eat in our diet, and that is the other category. So when we determine whether or not a pie chart can be used, we have to make sure that we have every single contingency taken care of. This other category probably would take care of things like chocolate or things that aren't necessarily that good for us. And we should only have about 5% of those things. And they don't fall in these other categories. So this other category is often used to fill out a pie chart to make sure that all contingencies are taken care of.